Hello everyone, I am Prabhu Reddy from Sri Venkateswara College of Engineering. I am studying in 3rd SEM Department of Electronics and Communication Engineering. Today's subject is Electronic Principles and Circuits. Subject code is BEC303. And the topic we are going to discuss in this video is feedback concept of voltage amplifiers, how it works, advantages, disadvantages, and etc. So let's start. First, let's see what is a voltage amplifier or what's it works. Voltage amplifiers are electronic circuits that increase the amplitude of electrical signals. They are used in various applications from audio to systems to radio communication devices. They simply increase the signals of the strength, input strength. If you give a low frequency or low amplitude input signal, the amplifier will be increasing its amplitude. For example, you can take the mic where you speak in a low pitch and gives the output in high pitch. Then the importance of feedback in voltage amplifiers. Mainly, the voltage amplifiers are used for amplifying the sound signals are these three reasons. First is stability, linearity, and noise reduction. Stability, it gives a good amplifying gain and output voltage, reducing the effects of components and doesn't even harm the components. Linearity, feedback system of voltage amplifier improves the linearity of amplifier response, ensuring more faithful reproduction of the input signal. And even it helps in noise reduction. The unwanted noises are cancelled through the help of feedback system in voltage amplifiers. Then the negative feedback concept. There are two types. First is negative feedback, and then we will go to the positive feedback system. In negative feedback system, the part or a portion of amplifier output is fed back to the input, but with an opposite phase. That is, if your wave is starting from the positive in the positive axis in the input, in the output it shall start from the negative axis. And even the opposing signals, the feedback signal opposes the input. That's what I said. The feedback signal starts from the negative if it input is from the positive. Hence it also improves your stability and linearity, and even it helps in reducing the noise, that is distortion. Then here we come to the positive feedback system. In positive feedback system, the feedback signal is in phase with the input signal, causing the amplifier to self oscillate. Here, if here there is no change in polarity of the signal between input and output, both waveforms sound similar. Uh, Positive feedback can significantly increase your amplifying sound gains, but it also makes the circuit or the amplifier more unstable due to its in-phase signals. Positive feedback can also be used in such as oscillators where we need not to give any input. The oscillator itself can produce its input signals and give us an output. That's why they are more prone to instability. Then effects of feedback system, negative feedback on voltage amplifiers performance, gain reduction. First is gain reduction. Negative feedback reduces the amplifier's overall gain, but also makes the gain more stable, but less sensitive to component variations. You get a linear waveform. You get a linear graph with no disturbances. It also increases your bandwidth allowing your amplifier to operate at higher frequencies. And also, it improves your stability, the amplifier stability, making it less prone to the oscillations or other disturbances. Advantages of negative feedback: same content is again repeated. It helps your signal output signal process of output signaling stability. It also gives a linearity in your graph with no disturbances. Also, it reduces other disturbances like noise disturbances, external sounds, etc. We come to the disadvantages of negative feedback. Negative feedback reduces the overall gain of the amplifier, which may not be desirable in some applications. In negative feedback, the waveforms are out of phase, that can sometimes leads to instability and oscillation if not properly managed. And negative feedback requires more and additional components, which makes the circuit more complex and also more expensive. Then we come to the considerations in stability of feedback amplifiers. First factor is gain margin. The difference between open loop and desired closed loop gain must be sufficient to ensure stability. The phase margin also is a factor. This was introduced by the feedback loop must be minimized to prevent oscillation and maintain stability. Frequency response. The frequency response of the amplifier and the feedback loop must be carefully designed to maintain stability across the whole operating range of the circuit. Applications of feedback voltage amplifiers. They are mainly you can see in your daily life is radio systems and when you speak through mic. They are related to your audio systems. In instrumentation, they are essential components in measurement and instrumentation devices, ensuring accurate and reliable signal processing. This can be seen in defense purposes or any police service related when they use their and negative feedback system or positive feedback system can also be helpful in communication systems where the radio frequencies and microwave communication systems to amplify the condition signals for transmission and reception. Thank you. Here our content comes to an end. Thank you for watching the video. Please like and share the video.